Hey guys, in this video we're going to talk about ANOVA single factor tests. And ANOVA is the basically it's the analysis of variance. So in t-tests we talked about various kinds of t-tests, and that was basically comparing the sample mean, right? And now this is analyzing the variance of the data set. So there's a couple of different kinds of ANOVA tests that you can do, and I just want you to be aware, making sure that you're following along with the right one, and how each differs from the other. Okay, so in this one, the question, the sample question that I came up with is: you are a pharmaceutical company and you are testing the efficacy of a new drug that you're producing, right? You bring 18 people for this test. 6 of them use drug X, 6 of them use drug Y, which is the competition drug, and 6 of them uses a placebo, drug Z. The drugs are rated from 1 to 10, and with 10 being very, very effective. So what can you conclude from the findings, and how well might you think the drug that your company is producing, drug X, will do on the market, right? So we go to data analysis, look for single factor ANOVA, which is the first one. Click OK. And the input range is very simple. You just select the whole thing, right? And I have labels in the first row. I output the data nearby, and I hit OK. Now, before I go into interpreting the data, I want you guys to make sure that you know the single factor ANOVA and what kind of properties that you need to have. So notice in the question I said there's 18 people. So every single one of these data points is a different person. Or a different machine if you're analyzing results from productivity or something, or a different process, or whatever it might be, right? But each individual data set here is a different person, and then there's 3 different categories, right? It's 2 or more. I think it goes up to like 16 or 25 for an ANOVA test or whatever, but it's 2 or more, and each individual person never takes a different test. So this guy over here never took the drug Y test, or never took this drug Z test. So that is something that you have to really keep in mind, to be like, oh, because of this scenario, I'm going to use ANOVA single factor instead of other ANOVA tests. So interpreting the ANOVA results. Okay, so here up on top, the summary part is once again more of the descriptive. And, there's 6 on each: the sum, average, variance, so on and so forth. And then on the bottom here is the more inferential. Okay, so here we have a F value and an F critical, right? So it's the same way of reading ANOVA as a t-test, right? The only difference is that there is never really a negative F value. It's just F values of smaller or greater than the F critical. And in this case, you can see that there's an F value that's significantly greater than the F critical. And the p-value here is very, very small. And if you don't know how to read this, it's 2.3 to the power of -5. So if you actually click the cell, you can see that the number up here is very, very, very small. So you can say that because of all these things, there is a significant difference between the groups. Okay, so this over here, it says the label here. Between groups, there is definitely a significant difference. Within groups, it tells you a couple of little pieces of data. sum of squares, degree of freedom, and so on and so forth. That's not so important here. This over here, the f, the p-value, and the f critical is what we're really looking at. So now you know there is a significant difference between the groups. You ask the question, well, how do I know how well my drug is doing, right? Because just by eyeballing it, you can totally tell there is a difference between the drug and the placebo. Likewise, the competition's drug also has a difference with the placebo. So you're wondering, well, how do I know whether the drug will do well on the market? You know, we know that it is effective, right? We can say that it is definitely effective, but are we going to outperform the competition? You don't know based on this particular test. So at this point, you'd actually have to run a t-test between x and y to figure out which one's actually better, right? Doing just the ANOVA in this circumstance won't tell you everything. So you actually should do a t-test between x and y to see, you know, whether your drug is better or the competition is better. So you'll know, you know, whether or not you'll do very well on the market or poorly on the market. So the answer, I pretty much said it all here, and that's really it for single factor ANOVA test. So once again, the takeaway is that you make sure you know the properties of the single ANOVA, single factor ANOVA, right? That these guys don't repeat the test, and then each column is a different test, so on and so forth. And next time, we're going to move on to two-factor ANOVA test without replication. See you next time.